Hello again, everybody. I hope you all are doing well. If you're seeing this, then you know that we have finished our unit on climate and moisture, and we are talking about our next unit, topic 8, rocks and minerals. And some of you are going, yay, and some of you are going, oh no, not again. I know you guys were introduced to this topic in middle school, so you have a little bit of experience with it. That's a good thing. So you will probably come across things that you've talked about in the past, and they're going to sound familiar to you. And some of this stuff will be new as we go into a little bit more depth. So have your notes packet ready, have everything out, especially your reference tables. I would also have a highlighter or a pen or a pencil just so you can make little notes to yourself as we go through certain pages of the reference table. You can kind of make little notes, little reminders on how to read the charts. So let's get started. Our first topic is, what is the difference between a rock and a mineral? And surprisingly, this is actually tough for some people because you look at a rock and you look at a mineral, and by eyesight, they look very similar, but there are some differences between the two. Minerals have 5 distinct characteristics, and rocks have their own characteristics as well. So we're going to go through minerals first. Okay, the definition of a mineral is a common earth material that are the building blocks of rocks. A little bit of a rhyme there. So these are the things that you will find very common on Earth, and these are kind of like the ingredients. I like to call them ingredients to certain rocks. So certain rocks will have one type of mineral, another type of mineral. They'll have multi different types of minerals, but you'll see how they kind of come together, these minerals, and they will build a rock. We'll definitely talk about that as we continue on. So, excuse me, guys. Minerals need to be solid. Okay, if you are seeing a mineral that is a gas or a liquid, please make sure that you're on planet Earth because that's not going to happen here. They will be solid. Okay, inorganic, and what we mean by inorganic is just non-living material. So these things are not alive. They never were alive, so they're non-living. Okay, naturally occurring, meaning not man-made. Best example I can give you about this one, guys, is the difference between a cubic zirconia and a diamond. Cubic zirconia rings, girls, guys, I'm pretty sure you know you can kind of jump into a store like Claire's and you'll see those pretty shiny rings, and they look like a diamond, but they are not. They're a lot cheaper than a diamond versus a real diamond. It's naturally occurring. It's made on Earth, like inside the Earth, with a lot of heat and a lot of pressure, and they are obviously more expensive. Okay, so but they kind of look the same, but one was made in a factory by man and the other one was naturally occurring, so that's going to make it a mineral. Okay, definite chemical composition. That's a bit of a mouthful. Basically, what this means is how it's made. Okay, it's made of certain elements that will that'll come together and they will make up this mineral. And you'll kind of see what we're talking about there because there is a part of this on the reference table that you'll see which minerals are made of what elements and their composition. So we'll talk about that a little bit more in detail. And finally, specific internal arrangement of atoms. And you're all going, what? How is it built? So I'm going to kind of go over here. I'm going to give you guys a second just to write that down. But basically what this means is it's the physical properties of the mineral. And I'm going to give you an example here. If the PowerPoint will go. Nope, doesn't want to go. Yeah. Oh, there it is. Okay. So you have here an example of graphite versus diamond. And graphite and diamond are actually made of the same, they have the same composition. They're both made of carbon. But if you look at the two, how they're built or the arrangement of the atoms is very different. So graphite kind of has a lot of space in between the atoms versus diamond where it's very compact. Now graphite, for those of you that don't know, is what your pencils are made out of. So you can easily write with a pencil. You'll see those marks come off from a pencil. So that internal arrangement of atoms is rather loose. This way you can break the mineral rather easily versus a diamond, which is the hardest mineral and actually the toughest thing to break. I think people, they do it by lasers in order to kind of shape it, but it's very tough to break. So that's how like the internal arrangement of atoms influences a mineral, or makes up a mineral, I should say. Okay, rocks. Okay, rocks are a solid. Again, if it's not a solid, just double check where you are, composed of one or more types of minerals. And I like to think of a rock as kind of like a cake. A cake needs ingredients. A rock needs one or more types of minerals. So the minerals are the ingredients to the rock, making up these different types of rocks like we talked about. Okay, and you have two types of rocks. You can have something like a monomineralic, which means it's only made of one mineral. And I know you guys have seen the word mono before, especially I think in history. You guys see that. And polymineralic, which is made of many minerals. So some rocks only have one mineral, some rocks made of many minerals. And we'll definitely talk about that more in detail. Okay. On your reference table on page 6, you'll find a diagram that looks just like this. And this is basically the rock cycle, as it says in the title. So if you take a look at this, you'll see that we have a couple of squares, or rectangles, I should say, and they're labeled as sedimentary rock, metamorphic rock, and igneous rock. And those are the three types of rocks that we're going to talk about. You guys, I'm sure, have heard them before. And you'll see that you have these arrows, and it kind of looks a little crazy at first, but those arrows are representing the processes that you'll have to go through, or the minerals and the rocks will have to go through in order to reach the destination of a sedimentary rock, metamorphic rock, or igneous rock. So it's kind of like a little map. So for example, if I wanted to take a metamorphic rock, excuse me, actually I'm going to do mineral, I'm going to do sedimentary. If I want to go from a sedimentary rock to a metamorphic rock, I would just simply follow the path like this, and you'll see that you need heat or pressure in order to change a sedimentary rock to a metamorphic rock. Some of the rocks have different processes or more than one process to go through. So for example, if I want to take a metamorphic rock and I wanted to go through to make it an igneous rock, you'll see that it goes through melting and then it hits the stage called magma, which we'll talk about as we talk about igneous rocks, and then up to solidification, and we'll get you to being an igneous rock. So it's basically a map. And all of those lines that you see with the arrows are just the processes that the sediments and the rocks will go through in order to become one of the three types of rocks. Okay, and again, we'll be referring to this a lot throughout our studies of rocks and minerals. So we're definitely going to come back and we're going to work with it, and you guys will see how these things happen. What do these different processes do? Okay, so let's turn the page, right? And we are going to start with minerals. So let's talk about minerals. How can we identify one mineral from another? And there are ways. In fact, you are going to have to do this if we have our reagents, but one of the lab practicals on the reagents will ask you to identify a mineral using specific characteristics. So let's get started on this. Right? Okay, you have in your reference tables on the very, very, very last page this long chart, and they are the common properties of minerals. And we are going to look at each of these characteristics on this graph, this chart. Okay, you have a lot of vocabulary terms here that are kind of hanging up north. You have north, or the top of the graph. You have luster, hardness, cleavage and fracture is over here, colors, distinguishing characteristics, uses, and look, there's that composition that we talked about. So all of these in this kind of column are the elements that will make up these particular minerals. That's where we're talking about composition. And then obviously the mineral name. So what you're seeing at the top of this chart is all of the things that we're going to look at in order to identify a mineral. Some are better than others, some are more reliable than others, but we're going to kind of dive in and we're going to take a look. Just one note, on the bottom, you'll see this thing that says chemical symbols. This goes with your composition. Okay, so you'll see that, let's just look, for example, at galena. Galena's over here. Okay, and you'll see that galena has this thing that says PBS. Oh, wow, that's actually pretty funny because it's actually a channel on your TV. Okay, and let's say for argument's sake, you're like, I don't know what that means. What does PBS mean? Well, if you go to the bottom of your graph or of your chart down here, you're going to see these chemical compositions, and they'll tell you what each of those letters stand for. So if you look for PB, that's over here, that's lead. And if you see S, that's over here, that's sulfur. Okay, so basically galena is made of lead and sulfur. Okay, that's pretty much what you have to know here. But we're going to really talk about these different characteristics of minerals and kind of break them down. So let's take a look. Okay, ways to identify a mineral. The first way you can identify a mineral. Now in your notes, you can see that they're kind of blocked off. So the first one we're going to talk about is color. Okay, so on the left-hand side, in that little skinny column, you can write the word color, and then we can talk about what it is. So easy to recognize, that'll go in the other box, but not very reliable. So hopefully at this point, everybody knows their colors. But it's not easy to identify a mineral just by looking at the color. And I'm going to show you why. So here I have two minerals, and they look to be the exact same mineral. Okay, they both have the same color, which would be clear. Okay, so different minerals can be the same color. It is very common. Okay, so calcite and halite are both colorless, or they're clear. Okay, write that down in the box next to color. It is just an example of that. So again, these two are both colorless. So if I showed them to you, you would have a difficult time identifying them just by their color alone. So we need a little bit more. Okay, and the other thing is an example of quartz. So not only can they be the same color, but they can also be different colors. So what you're looking at here is quartz. They are all the same mineral, but you have a white, a pink, and a purple. So that could be a little confusing. So definitely not the most reliable source. Okay, and if we go back here, let's just do this. I'm going to make it green. Okay, if we go back here, you can see right here it says common colors. And all the way down this column are the common colors that you would get for particular minerals. So if I'm looking at graphite over here, its common color will be silver to gray. Okay, again, not the most reliable source, but something to take into consideration. Okay, the next one is streak. Now, streak's a little bit more reliable because this is the color of the mineral's powder. So even if the mineral comes out in several colors, the streak will be the same. So it's a really good way to identify a mineral, or at least narrow down the choices you have of the mineral. So the fun thing about streaks, okay, is you have to test it on this streak plate. Okay, and what you do is you take the mineral and you have a porcelain plate and you just press the mineral against the porcelain plate and you just kind of, for lack of a better term, streak it across. And what it's doing is it's leaving behind its powder, what it's made up of, and it's going to be a specific color. Okay, this is a great way to kind of tell the difference between certain minerals and what they are, because all of them have a very specific streak color. And that will not change even if the mineral's color changes. Okay, fool's gold is really big for this. Fool's gold, or pyrite, looks gold in color, but when you put it against the streak plate, it actually comes out to be a black color against the streak plate, and that's why we call it fool's gold, because outwardly its color looks like a gold color, but unfortunately when you press it against a streak plate and you check the color of its streak, it's black. So it's kind of, that's why we call it fool's gold. A lot of people got tricked by it. Okay, and you will see, let me see, that streak plate. Now, in our reference tables, we don't actually see a column that is just for streak. But if you look at the distinguishing characteristics over here, sometimes they'll have an actual streak reference to the distinguishing characteristics. So if you find pyrite, for example, because we were just talking about that, okay, pyrite, if you look at that distinguishing characteristics, it does mention that it has a green-black streak. So just a reminder that there's no actual column for this, but you'll be able to find it usually in the distinguishing characteristics, or it'll be part of the question, or they're going to give you a chart that will specifically mention the streak, but in the reference tables, that streak will most likely be listed under the distinguishing characteristics. Okay. So let me just erase that, and let's move on. Luster, which I'm not quite sure why so many students struggle with this, because luster is just something that's metallic or non-metallic. It's a reflection. So hopefully you know what a metal looks like. And I think what a lot of students get confused with is because when they see it shine, or it looks like it's shiny, for whatever reason we think that it's metallic. So I'm going to give you an example. Metallic looks like a metal. Okay, it reflects, it looks very, again, lack of a better term, metallic. Think about things in your house that are metallic. Okay, if you look at your phone charger, the end of the block, you have those two little prongs, that's metallic. Okay, so these are things that you want to make sure that you're able to recognize. Galena, also metallic. Now, I want you to take a look at the non-metallic and note to yourself some of the differences here. Something that is metallic has a shiny characteristic. Non-metallic, it's not shiny. So just because it might look a little glisten, it might glisten a little bit, or it looks smooth, does not mean that it is a metal. So just kind of recognize that. Okay, that is on here, and that's right here where it says luster. Okay, and on the side it'll say metallic or non-metallic. Now you can see, and there's only one. This guy is over here. There's only one where they could be either or, but we don't usually give hematite a lot. So, but he is either or. Okay, and you'll see not many minerals are metallic, right? Graphite, galena, magnetite, pyrite, those are going to pretty much be your metallic ones. Everything else, for the majority of what you'll come across in this class, is it looks like to be it's non-metallic. So hopefully you'll be able to recognize. Remember, it shines like a metal, it is metallic. Okay? Just because it's smooth and it reflects some light doesn't mean that it is metallic. Next one on the list, hardness. I do enjoy this one. I like hardness because it is a fun way to test it. Okay, hardness is the ability, or the mineral's ability, to being scratched or be scratched. So it's kind of a resistance. So something that's hard is a hard mineral will not be scratched easily, but it could scratch other minerals. On the flip side, you can have a mineral that is scratched easily, and it cannot scratch other minerals. And we use this scratch test and the Mohs hardness scale to kind of determine the hardness of a mineral. So glass, we use glass, which has a hardness of 7. And what we do is we take the mineral and we press it against the glass, and we see if it leaves behind an indent, okay? And that little streak, or that little scratch inside or on the glass, will actually determine the hardness. Now, we do a little bit of rounding here, okay? Oh, I don't know why I have glass as a hardness of 7 over there. I apologize, guys. Glass hardness is 5.5, not 7. I apologize for that. I don't know how 7 got in there. Okay, so we use something called the Mohs hardness scale, and that goes, and these are kind of your common ones. So talc being the softest, and diamond being the hardest, just like we talked before. We were talking about before. So something like talc here, talc is going to be scratched easily because it's soft. It actually, I think you can actually break it apart in your hands too. Versus a diamond over here, now that diamond is not going to be able to be scratched easily. However, it can scratch all these minerals. So diamond can scratch everything on this list, okay? Now, if I looked at something like calcite, which is a little bit in the middle, calcite can scratch gypsum and talc, but it cannot scratch any of these guys. So fluorite, apatite, yeah, feldspar, quartz, so on and so forth, okay? If I'm sitting right in the middle, okay, he'll be able to scratch all of these minerals, but will not be able to scratch any of those minerals. Right? So kind of giving you a little bit of a visual of how these work. So your fingernail is 2.5. That's the hardness of your fingernail. So your fingernail would be able to scratch gypsum and talc. A penny is 3, has a hardness of 3. And like we said, glass has a hardness of 5.5. So what we do is we take the mineral, we streak it or press it against a glass plate. Now, if it leaves behind a little scratch or an indent, that means it's harder than glass. If it doesn't leave behind a scratch or an indent, that means it's softer than glass. Now, this can get a little confusing because sometimes you can get a piece of glass that's got a lot of scratches in it. Usually what I like to do is after I do the scratch with the mineral, I'll run my fingernail over where that scratch went, and if I feel like it scratched into the glass, then I know it left behind a scratch, okay? Looking over here, now let's take this. So let's say your mineral, like this, that would be quartz, left behind a scratch in the glass. That basically means that it's harder than glass. So if I look here, remember, glass has, let me write my little note here for you guys so you can see it. So glass, oh, that's not what I wanted. Pardon. So glass has a hardness of 5.5, okay? So if the mineral scratches glass, that means it's going to be higher. That number is going to be higher than 5.5. So if the mineral scratches glass, so let's say scratch, it's going to be higher than 5.5. And if it does not scratch, it's going to be less than 5.5. All right, so if we look at, let's just go back and take a look at quartz. Let's find you, quartz. Where are you? There he is, all the way down at the bottom, okay? You'll notice, if I go all the way over, so here's your hardness scale right here. If I go all the way down and I see where the hardness of quartz, you can see that it's a 7. And if we would go back and we looked at that picture, you would see that they left a scratch behind. Therefore, it is hard. It is harder than glass, and it should be a number that is higher than 5.5. Okay? Some of them are kind of in betweens, right? So like this one, biotype mica is 2.5 to 3. That's okay. That's still not as hard as glass, so it wouldn't leave behind a streak. I'm sorry, a scratch. Got to be careful what you say, because streak is a very different thing. Okay? Breakage. This is another tough one for students to kind of understand. And I get why. Sometimes it's hard to see certain angles, but we're going to break it down as simply as we can. Okay? The breakage boils down to 2 different characteristics. That would be cleavage versus fracture. So cleavage is a tendency for that mineral to split and make smooth, flat surfaces. So you want to look for something that has nice angles, flat edges, nice and smooth and flat. Fracture, on the other hand, is the complete opposite. It's the mineral will now break into pieces with uneven surfaces. And sometimes what happens with students is that they look at it and they see one smooth side and they go, it must have cleavage. Remember, this is the entire mineral, not necessarily just one side of the mineral. So let's take a look at some examples. So here's examples of cleavage. Okay, if I took that mineral, which I believe is calcite, and I hit it with a hammer, I would get still smooth, nice edges, flat surfaces, because that is the way the atoms are arranged inside this mineral. So no matter how many times I hit it or how small I make those pieces, they will still come out with smooth, flat surfaces. Okay. Oh, look, can I get that? I don't know if we can see it. No, maybe. Nope, sorry guys, I thought that was going to pop up. It doesn't. Okay. Fracture, on the other hand, as you can see, that is not smooth and flat surfaces. It's very bumpy, it's very rough. And if I hit this mineral with a hammer, it would also come out with fracture, would also come out with rough, not smooth edges, uneven edges, and so forth. Okay. So what I would do is I would go on Google, because I know most of you have been, and just go and look at different types of minerals and try to see if you can visualize which one's fracture, which one's cleavage. Okay, just kind of make notes of those. There's another one for fracture. Again, not smooth, very rough, uneven edges. Okay, and we do have this on our charts, and it is right there. That is cleavage versus fracture. Remember, cleavage is smooth, flat surfaces. Fracture is not. And you'll see that they'll just put a little check mark on the side that would say if it's cleavage or if it's fracture. Okay, you go down right down that column. All right. Some of them get special properties, and this is kind of cool. So we have something, this is not for all minerals, this is just for certain minerals. We have something called the acid test. And calcite, because of its composition and what it's made of, if I put acid on calcite, it'll actually bubble. It's actually very fun to see. Okay, it's a chemical property of calcite. It's actually one of the ways we can tell the difference between calcite and halite. Okay, and it's a cool little special property. It's pretty much for calcite in this case. And the other things we have are double refraction. Some minerals are magnetism. They do have iron in them, so you get a little bit of a magnetic pull, and specific gravity. So some minerals have a very high density compared to others. That was weird. So just to kind of show you an idea of double refraction, let's take a look at that picture. You see how you can see calcite, and then underneath it looks like calcite again. That's what double refraction looks like. Okay. And those are just some of your common minerals. So why don't you take a moment at the end of this and send an email to myself or Mr. Zanville. And I'd love to see how many characteristics you can name. Obviously, you can't do hardness and you can't do streak, but maybe you can tell me cleavage versus fracture, metallic versus non-metallic, things like that. See how many things you can identify just by visually looking at these, especially cleavage versus fracture, because I feel like that's a tough one for students to get. Okay. All right, that being said, We have reached the end of our lesson for minerals. So you have a couple of questions to answer. Mineral questions, multiple choice mostly, a little bit of short answer. So if you guys would answer those questions, and then we will continue on to the next video when you guys are done. And I will speak to you soon. Take care, guys.